And Sonali is going to share her screen, right? To be Sonali talking about the nova in Cassiopeia or Cassiopeia, depending upon your proclivities of language. Let's see. And Sonali is going to share her screen, right?
Yes, let me make sure my correct window is open.
We can see you.
Yeah, but she's trying to get share screen work.
Okay, so the nova in Cassiopeia, this was just something I came across. I think John Larson put it in Discord, where he got it from Twitter. And I'm always interested in trying to see something different, new. And I do follow some of the nova and supernova discoveries on my own. I don't really do much other than read about them or take a photograph. And so this had me pretty interested. So I searched it in Google, and I found out that it was magnitude 9.6. So something you could see in your telescope or your binoculars. So the next night I got out there and I had my binoculars and my camera. I was not able to see it with my binoculars because the time that Cassiopeia is now out, it's low in the horizon. And I was out in the parking lot, so we had parking lot lights. But I did manage to take a few pictures in the general vicinity of Cassiopeia. I had figured out it was close to M52 or the Bubble Nebula. And when I came home that night, bingo, it was there. So I was really excited that I had managed to get this. But as you can see, I'm not calling it a supernova, I'm calling it a nova. And that brings me to this presentation as to, okay, so what is the difference between a supernova and a nova? And why is this a nova in Cassiopeia and not a supernova? So the term supernova was actually first used in the 1930s. Walter Barry and Fred Zwicky at Mount Wilson Observatory used this. They were observing S Andromedae, also known as SN1885A in the Andromeda Galaxy. And as we just had this little discussion earlier, the supernova is basically an explosion of a massive star at the end of its life. And as Steve Skinner mentioned in 1572, Tycho Brahe coined the term stella novae, or a new star. And if you actually look at the definition, we know now it's not a new star, it's an older star that we have termed as a new star. We're all familiar with the most famous supernova remnants, M1 or the Crab Nebula and the Veil Nebula, which are spectacular sights. So what is a nova? A nova is actually seen in a binary system where the dwarf star siphons off matter from its companion star, which is actually a regular star. Now, over time, there has been different classification of supernova or nova, and this has changed because as our instruments get better, as we look at the sky better and understand the universe a little better each time, the classification changed from observation based on spectra to based on cause. And the first classification was introduced by Rudolf Minkowski and Fritz Zwicky, and it was called the Minkowski-Zwicky system. And this was based off on, the hydrogen absorption line seen in its spectrum. So they labeled them as type 1 and type 2, and we still use these terms. As you can see, type 1 does not have the hydrogen absorption lines in its spectrum, and type 2 does. And as you can see at the bottom of the screen, when you classify based on cause, type 1b and type 1c now fall into the category with type 2, whereas type 1a is a special kind of a supernova based on cause. As type 2 is a core collapse and type 1a is based on a thermonuclear reaction. Now, this is a lot of writing, but I'm going to start off with the space place from NASA. And let me see. This is a very simple little graphic from NASA, but it explains it very simply. I think this is more geared toward classrooms, but it has nice diagrams, which I could not replicate.
I have a question, Sonali.
Yes.
Did you click the link to show something? Because we're only seeing your presentation.
Oh, okay. So I guess I did not share my whole screen, so maybe that's why. Are you seeing it now?
Mm-mm. I think it was just shared that program.
Okay, let's do it this way. Okay, so there's a way to share everything, right? So
Mm-hmm.
advanced.
Usually it'll say like screen 1 or screen 2, and then, or you can choose the programs below it.
All right, let's just go to this. Are you
Ooh,
seeing
yes, that's
this
kind
graphic?
of a
Okay.
neat. Yeah.
So this, like I said, is very simple. This is a illustration of a supernova. And this is a basic explanation. And basically it's called, they call this the last hurrah of a dying massive star. What do you mean by massive? Basically supernovas are type 2. So it's a core collapse. When we say massive, the solar mass has to be about 8 to 25 times the mass of the sun. And normally you have fusion at the center, which, you know, you fuse hydrogen to helium, then carbon. In these stars, the fusion goes all the way to iron. And at that point, the nuclear, as it says, the core itself, as it's fusing, causes an outward pressure because of its energy and gravitational inner force, as you can see here. When the core becomes denser and denser and it runs out of fuel, it cools off. So this causes the pressure to drop, gravity wins out, and the star then collapses. And then as it collapses, it again compresses, causes an enormous shock wave, and that's what we see as a huge supernova. And here is where all other elements in the universe are born out of a supernova. So when we talk about gold and all the heavier elements, that's where we get it. Now, if the star is really massive, more than 5 solar mass, when the core. So when we talk of how massive, we're talking about two things: the mass of the star and the mass of the core. So if the core is more than 5 solar masses, this can become a black hole. But if the core is greater than 5 solar masses, you get a black hole. If it is less than 5, then you can get a neutron star. So we come to what exactly is a nova. And this is an illustration of a nova. Basically, that is a binary system which has a dwarf star and another star that's a regular star. The dwarf star accretes gases from the main star, and then when that reaches a certain level, it blows it off, and so that becomes a nova. So then this just goes on to, you know, study about supernovas and stuff like that. So let me go back and go to the other screen. Oops. All right, I am trying to find the Zoom screen here, and I seem to have.
I know the feeling. Yes.
Okay. Well, I try to figure out where my Zoom, there we go. Okay, so that brings us back to, that was a basic idea of what a type 1 and a type 2 supernova. And the one in CAS is really a type 1 supernova, or a type 1A. So basically, these originate from white dwarfs in a closed binary system. the gas of the companion star accumulates onto the white dwarf, which then progressively, gets compressed. So as it gets compressed, nuclear fusion occurs and the star brightens and expels its outer layers, forming a nova. And there's also a certain limit that is called the Chandrasekhar limit. I've spelled that wrong. But basically it is the limit, which is 1.4 times the mass of the sun, that needs to be reached before a star either implodes as a supernova in the case of type 2, or in case of a white dwarf, if it behaves like a type 2, then as it accumulates gas from the other star, if it's big enough and it comes to that, that can also then explode. So it's actually all very interesting if you look at it through how it, what the underlying cause of a nova or a supernova is. You know, there's a, as you can see with type 2 supernovas, these are stars that start off between 8 to 15 solar masses. When they run out of hydrogen, they fuse helium, and further down fuse carbon. So the heavier metals build up at the center and the lighter ones are in the outer layers. Now, when the core passes a certain mass, again, the Chandrasekhar limit, which is 1.4 times the mass of the sun, it implodes. The core heats up, becomes denser, and then explodes as a supernova and leaves a neutron star. If the core itself is less than 5 solar masses or greater than 5 solar masses, it leaves a black hole. So these are certain websites that will sort of help in trying to figure out what are the latest supernova and what it is that you are seeing. So one of these, this website is basically, can you see this?
Yes.
Yeah. Yes, thank you. This shows you, this is an article in Sky and Telescope, which shows you where M52 is, the bubble nebula.
We don't see the article.
Oh, you're not? Okay.
We're seeing the links.
Links.
Sorry, let's go back to the screen. Now?
Yes.
Yep.
Okay. So this is a very beautiful picture of what M50, where M52 is, bubble nebula, and the nova. And this is exactly where it's at. And it is visible through even a smaller telescope. And of course, in a photograph, if you through a DSLR. And they just go on to talk about this. And this is a little picture showing about the white dwarf and a star. Now, the other website that they've mentioned is the AAVSO website, which helps with variable stars. And that is another website that you can use to figure out what you're looking at if you've taken a photograph or you're looking at the sky. And these charts are easily available. As you can see, the nova has been named V1405 CAS. And this is a star chart from the AAVSO website that gives you an idea of where it can be found. Okay. Now this is a website, which again, I will share.
I'm also putting the links in the chat for people from your presentation.
Thank you. Now, this website is the Rochester Astronomy website. This is really a cool website. And once it feels like a lot of information and type, but once you understand what all this shows, I can get lost just looking at stuff on this website. So these are the names of the newly discovered supernovae. This gives you the magnitude. This gives you, is it in a host galaxy or is it, where is it? And these mostly come from the various surveys. So like the Atlas survey, the, Gaia, and you can see a list of what they have. If you click on any one of these, it takes you to something called the TNS server. So for example, let's click on this one. Now this gives you the picture of where the nova is. And as you can see, this is just a black and white picture. It tells you who discovered this. This was discovered by Koichi Itagaki on 2021, 17th of March. It gives you which galaxy, NGC, where it was. It gives you the RA and the declination. And what I find really interesting is when you come down to images, this tells you that someone has actually taken images, and you can see what these images look like. And it tells you exactly how they took this image. This was a 6 point. This was a reflector with a CCD. If you go back to the same place and go to the TNS server, then it gives you an idea of, you can look at Simbad, you can look at the Sky Mapper and all these other sites. This is another easier one to just look at, and it tells you where it is. Though this is a little more difficult, at least for me, to use. But you can zoom out and see where it is. And you can do this for pretty much everything. It gives you, as you scroll down, the spectrum of the star or the supernova. Sorry, if you want to see the oxygen absorption lines, you can do that. You can glean a lot of information from these websites. And it gives you, other people who have looked at that. It gives you the classification, discovery. So this can take you down a rabbit hole, literally. And I had to stop myself there before I went down that hole myself. So these are just a few examples of the websites. That website also has a link to other links for information on supernovas and novas that you can read. So this is something that after I read that first initial article, I went out on March 19th and sat there and took photos with my DSLR. And this was the picture I got. Now, I had really no idea where I was in the sky. It's a bunch of white dots. So I use a website called Astrometry. So this is what it looked like, even before I got to the point that I could point an arrow at it. There is a website called astrometry.net. If you take your picture or your photograph or whatever it is you have, and you go to this website, which I will share again. This is what it looks like. You can sign in. I'm not going to actually demonstrate what this website does, because when you try and upload a picture, it takes it says up to 10 minutes, and it can take longer. So you pick the picture that you have taken and you upload it to this website. That's all you have to do. If you sign in, you can choose to make your picture, whether you want it to be visible to the public, you want to let them use it for commercial use or not. Once you upload it, it tells you exactly, you can choose a lot of these things, but I leave it as default. After you do all this, it shows up as a report. And this is this is what it looks like. So I have actually cropped the rest of it out, but it basically showed me on my whole photograph where forecast was, where M52 was, the bubble nebula was. And after, looking at the internet, looking at all those images, I knew that this was in this vicinity. So all I did was magnify my own photograph, and I found it right there and compared it to other photographs, and I knew I had it. So this was all very exciting. So this is what this is what I got from astrometry.net. As you can see, I had a really wider field, but I knew it was somewhere here. I just wanted to make sure I had the right stars. So if you're going to go out and look for this, and you know where M52 is, you're already there. If not, you can look for 4 Cassiopeia, or this is, I believe, Beta Cassiopeia, and you can find yourself where you are and where you need to be. Now, having done that, for the next clear night that I could go out, we were out and it was cloudy, but we used binocular. I used binoculars, couldn't see it, had set up my little smaller telescope to see this. And we actually managed to see the nova through a telescope. So I thought that was really exciting. I know this weekend is supposed to be dark skies. So hopefully if you want to give it a shot either with binoculars or a telescope, I think you should definitely give it a try. And that's pretty much all I have. It was just a short presentation of something I found exciting in the last few weeks.
Do you know how bright it is as of now?
No, but I could see it through my 102 millimeter Mac on Wednesday when seeing and cloudiness was bad.
On Wednesday?
Mm-hmm. I did not take pictures because it was visible for just barely 10 minutes when the clouds moved away.
Hmm.
Did it look different from Monday?
Oh, sorry, Monday. What am I
Oh,
talking
okay.
about? Sorry, I meant Monday. I'm not sure why I said Wednesday. I have my days mixed up. Sorry. Thank you, John.
Sure. Now, if I recall, when your picture versus your eyepiece view was mirrored, wasn't it? So it was flipped,
Yes, it
which was
flipped.
trick and sorry.
Yeah, it was flipped. Thanks. I thought I'd put those pictures in here, but I did not. So when I looked through it to my eyepiece, I realized that it was flipped, and I looked at those pictures hard enough that I knew I had found a little trio of 3 stars that helped me point to this nova. So all I did was I had downloaded this photograph to my phone so that in the field I would know what set of stars I'm looking at. And what I did was I turned my phone around to match what I was seeing in the eyepiece so that I knew exactly where to move and how to move my telescope to get to the nova, to get to that same star pattern. So that is another trick I've learned, is that if you've already taken a photo and you know what your eyepiece picture looks like, is to flip it around and take a photo of what it would look through your eyepiece and then find your way.
Awesome. I put the coordinates in the chat. So it's right ascension 23 hours, 24 minutes, 48 seconds, and declination is plus 61 degrees, 11 minutes, and 15 seconds. If your software for your telescope allows you to manually enter coordinates, you can put that in there and it will slew your go-to mount to find it. Or you can star hop. Any other questions?
Sonali, you talked a lot about supernovas, but you only briefly mentioned nova at the very, very beginning. Just to repeat, a nova is different from a supernova, and a nova can recur, and a supernova is kind of a one-time event because it's cataclysmic and the core collapses. You don't have left what you used to have. Whereas the nova, the thermonuclear reaction that happens on the outer layers of the star, and the core star, the white dwarf, etc., remains pretty much unscathed after a nova.
Right. And so, yes, as the gas from the neighboring star accumulates on the core, you're right, that as that gets denser and reaches a certain mass, the fusion process occurs in the outer layers, and that gets blown away to leave the original white dwarf, which can redo this process again and again. And
how much time elapses between the two events? Millions of years?
I suppose that would depend on its companion star and how big or small the companion star would be and what the life of the companion star is. Whether it happens again or not.
Yeah, it typically doesn't happen in short order. It
Right.
takes a period of time, and the companion star can be damaged during the nova too. It depends on the different circumstances, but yeah.
Yeah, I think, a supernova is pretty easier to understand. If the fusion goes on, it's a big, massive star. All the layers happen, the core collapses, and it bursts. And it's basically, like Louis pointed out, it is the end of life for that star. But in terms of a nova, it may be a recurring phenomenon. How long it happens would depend on the size of the companion star, where that star is at in its phase of life. And so it's hard to tell. It depends on just that binary system itself.
And again, the star that novas is typically unaffected by in the overall scheme of things. It's not really affected by the nova itself. It
Right.
survives beyond that. It's already dense and not much left to do it, and
Yeah.
unless you can drop a lot of mass on it.
Right. And there is an explanation for that exact same phenomenon is if the white dwarf is already close to the Chandrasekhar limit to begin with, and then you have more mass accreting on top of that, it then behaves like a supernova. So that was an interesting thing I read briefly, but not in great detail. There are lectures on the internet from Ohio State University that I did look at, and some other universities that really explain this in great detail and very simply, other than Wikipedia. But
Steve, do you have a question?
Yeah, just I've been looking, Sonali, to see if anyone has calculated the distance to the nova, and I haven't found anything. But you've maybe looked more widely. Have you found any mention of?
no, actually, the Sky and Telescope article that I talked about has located the other binary star.
Okay.
I am not sure where that is. I believe this has a link here. This talks about, they tried to identify as to what star was in its place before.
Mhm.
And this is an eclipsing binary star called this number.
Okay.
And they think this is the regular star next to the white dwarf that now we see as the nova. They are, main sequence stars that burn hydrogen, not like they burn it like the sun, not the end of the road white dwarfs. So actually, if you click on this, which I have, it takes you back to the AAVSO website, which tells you here's the nova. And if you look for stars where it says search nearby, it tells you, and for some reason, this is not doing anything. Here it is. I'm not sure. But anyway, this actual link really does work. I'm not sure why not, but it takes you to other candidate stars. There it is, other candidate stars. And it shows you this is how they found the star. It tells you what the distance is between these stars. And that's why they think this is the star that it's close to. And that's part of the binary system. And as you can see, magnitude range for V 1405 gas is currently listed as 7.5 to 15.6. So if you look at these other stars, they are further away compared to this one, which is why they think this is the candidate that's close to it.
Okay, good.
Do we have any other questions? I need to lower Steve. Okay, so what should we say? 5 minutes, and then we will start the business meeting. Okay.
Sounds good.
Sorry.
Back. Okay, so we're gonna do our business meeting now. And first up will be the secretary's report. I'm gonna put the minutes up on the screen, Diana.
Yes, I refer everybody to the minutes
Wait a minute, I
as
gotta find the
posted
right-
in
there
the.
it is.
Well,
Okay, this screen here. Okay. Do you want me?
Give everybody a second to look them over. Very brief summary. There were 31 members at the meeting on March 5th. There was a Messier Marathon scheduled for March 20th and 21st. Nebraska Star Party registration is open. Sonali received an award for her Saturn-Jupiter conjunction observations. There was a presentation about March observing events to look forward to. There was a in-reach scheduled for club members only at Astro Park on March 6th. Telescope loan program. There were 2 telescopes that have been loaned out for quite some time to people who were no longer members. And there was Stafford Pellish was going to take some steps to retrieve those. We are still short a program chair. And so OAS is forming a committee to find a new program chair since Lee had to resign. Tool Time showed, Kendall showed some photographs of the Pleiades and Mars. Louis Dorland showed a website that displays a webcam showing the aurora from Alaska. And Kim Moss Allen shared the story of a meteor fireball and how to report it to the American Meteor Society. The program was a video on understanding the universe. And I'll refer people to the business meeting minutes for the information there. And that basically sums up last month's meeting minutes.
Okay. Are there any corrections, additions to the minutes as they were read? All right. Is there a motion? Okay. Call for a motion to accept the meetings as read. Is there a motion to accept the meeting minutes?
This is Tom. I see you.
Tom Wilson.
This is
And who seconds?
this is Joe Shavlik. I second it.
Joe, and can you spell your last name for me?
SHAVLIK.
Thank you. I can't see you on my screen right now, so I did that for my benefit and for our secretary. A motion has been made and seconded to accept the minutes as read. All those in favor say aye.
Aye.
All opposed say nay. It carries. Boom. Treasurer's report.
We received $174.97 in dues, a $120 cash donation, $23.14 from Amazon Smile, for a total of $318.11 last month. And there were no expenditures. I did just now today pay for the post office box for $118, but that's in May. That's it.
Thank you, Mike.
Yeah, maybe you could mention that sometime about how you could set that up for the Smile.
The Smile, you just have to go to Amazon Smile, smile.amazon or whatever it is, website.
Sure. Yeah, I
Otherwise
mean, I went in and did that, but I didn't, I hadn't known about it until I heard that in the treasurer's report the one time, and then I went and looked and, maybe make it a mention at the beginning of a meeting or something, or or now, I suppose, since it's brought up. But yeah, it was easy to do.
It's just a
Sorry,
choice
Cancer.
of buying from Amazon Smile rather than Amazon.com. Price is the same.
So when you go to smile.amazon.com, then you essentially sign into your Amazon account.
You do. Everything else is the same.
Then you search for the Omaha Astronomical Society to choose it. And then whenever you do your shopping, just always go to smile.amazon.com.
And you don't have to choose again. It just it knows what you want.
Sure.
Change it.
But if people just go to Amazon, like they get a link from somebody and they don't go to the Smile version, it doesn't apply it. That's what I mean.
Right. Although one thing you can do is you can, if you go to a link and it takes you straight to Amazon, put the items in your
in the cart,
and then go back to Amazon Smile. They'll still be in the cart on Amazon Smile.
Mm-hmm.
Is there a separate app, I think, too, you'd have to use if you're shopping on your phone? I think there's a Smile app versus just the regular.
No, I don't think. I think it's the same thing. I use Amazon Smile.
I don't know about a separate app though. I haven't checked.
I don't do it on my phone though. I use my computer.
I'll have to look it up and see, because I'm curious about that too. Because sometimes if I'm at my grandmother's, I'll order light bulbs and I just and have it go, and I just think about, oh, whoops. Well, I never thought about the Amazon Smile component of that, so I'll have to look that up.
Yeah.
Make a note.
There have been a few times when I've logged into my Amazon account and it has come up and said, you have a charity set up under Smile. Do you want to log into Smile? So sometimes it will help you there. But yeah, if you're on your phone and you're in an Amazon app, I would think that you would need to change something to get into the Smile part. But having gone into Smile and set up a charity, I think Amazon will help you get back into the Smile part.
It does. You have to do it, but it reminds you. You're right. Sometimes.
They just have the regular tablet.
You can turn on Amazon Smile in the Amazon mobile app.
Oh, good.
There's instructions on how to do it on Amazon.
Great.
But it says it's not available for iPads and other tablet devices.
So you have to use the phone app version.
It's your phone, iPhone and Android phones.
Okay. Thank you.
If you're on one of those other devices, just go in through the website. Don't use the app.
Right. If you're using a tablet, you go in through the website. You don't need to use an app.
Yeah.
But if you're using your phone, get the app, and then it says open the app and find settings in the main menu. Tap on Amazon Smile and follow the on-screen instructions to turn Amazon Smile on in your phone. So yes, you can get Amazon Smile using the phone app.
Oh, there it is. Turn it on. Thank you. I just did.
Yay.
All right. Woohoo. Mission accomplished.
We learned something.
Yes. Vice President's report. Rodney is not here with us this evening, so I will briefly talk about it. There was a work day down at Astro Park last weekend. Rodney and Rodney's dad and Mike. I'm going to ruin your name, Mike.
That's all right.
Moderson.
Very good.
There we go.
Moderson.
Oh, I even wrote it out on my pad. I didn't look at the pad. Okay. So they went down with a couple of chainsaws and took down some trees that were pretty tall. We had gone out at the beginning of March, the same day that the InReach event was held. And we went and we marked some of the trees that we considered that were going to go down. I could not make it in the morning. I had other commitments. But I did stop out in the evening and take some pictures. So those were several of the photos that were down. If I go to here. So not only were the large ones down, the smaller ones were down. So parts of the Astro Park may seem a little bit bigger than usual because of the sections that were. Oh, there's a little cardinal in the tree.
What are you going to do with all that wood?
Take it if you need it.
You want it?
Make some nice turning stock.
Yep, that's what I'm going to go down and get some.
Okay.
Who else is turning?
It's big.
Who was that I was just talking to?
I'm sorry, John Wright.
Oh. Yeah, there's some nice cedar down there.
Yep.
Yeah.
That's a fairly large tree.
So who was at the workday? Rodney's dad, and who else?
Me, Mike Moderson.
Modrcin.
Okay.
Rodney's dad's name was it Tom?
That sounds right, but I could be mistaken.
It was Tom. I wrote it down. Okay.
So you took them down towards the farm?
I guess Mike's the only one to answer that question.
In what regards, like the way they fell?
To the south of the lot.
They were all towards most of them were kind of towards the southwest.
Okay, this picture that's up
south.
right now, you guys have to watch walking
southeast,
around there. But this picture that's up right now, you have to watch walking around there. There is an old odd house that's not there, but the hole is.
Oh.
It's been years, so it's not. It'd be a glory hole to a metal detector, but it's pretty deep still.
Okay, so be careful walking around.
Yeah, so if we get down there, we should look around for it and put some of the bigger logs in it.
Okay.
Was that go back? Can you go back one or two there? Is that a branch that's just hanging in that tree?
Yeah.
Yes. So be careful of falling branches too.
I don't understand how we missed
Oh.
that one.
It's easy. Years ago, before we took all the trees out, me and my nephew went down there and we took a tree that had nothing around it, but as it was falling, another tree jumped in its way. So we had to take 4 trees out just to knock one down.
Yeah, we had a little bit of that, but not. I can't believe we just left that hanging there like that. We'll maybe I'll maybe fix that.
No, John just went down and put it up there for looks.
Yeah. I used the drone. It was easy.
Yeah.
Craned it up.
Has anybody been down to the site to see if the skyline's been improved? I'm sure it has, but there's no leaves on the trees right now. So
right. I was gonna go and try to do some new. I did some pictures in November. We did some 360s and some other ones. I want to redo those sets to try to have some amount of a comparison.
Are you going to take the drone down again?
Oh yeah.
Yeah, that'd be good. I want that log right there.
You'll put your name on it?
No, that thing's pretty heavy.
Yeah.
Remember, I can't lift crap.
So
I might try and mill a couple of those into some slabs. And Rodney said that you were thinking about maybe building some tables or something out there.
Yeah. Originally, there's some trees we were going to cut and make benches out of them. Just cut them into slabs and then make rough benches out of them. But those trees are to the west of that area there.
But yeah, we left a couple of those trunks big. I can probably work on that at some point. Try and mill some slabs and be
Yeah,
kind
you
of
can
neat
cut
to have
some
them.
good sized ones with chainsaws and then let them dry. Put them together.
Yep. Maybe make a picnic table too or something.
now, for those who don't know, that there is a lot of
Limestone.
rock,
Limestone.
and you can kind of see how the trees have pushed things up or things move around. But what curious was me is I was standing there and I took this picture and I noticed, what is that?
Little critter.
No, it's gray.
Looks like a car battery.
It's a car battery.
Are you kidding me?
And it's shoved under a couple of rocks. So,
Where was this picture at? Comparison to the Odd House.
It is to the west of it.
Yeah, that's could be that guy that had come up there a lot. Also, watch out for bull snakes. They just scare the crap out of you.
Yeah. Well, I want to take a
Yeah, we need to get that
battery
out of there.
case and get it out of there. It moves easily, so.
Okay.
But yeah, look at the roots on this tree.
Oh yeah. You got to look. They're on top of the dirt that's on top of the rest of the quarry there.
Mm-hmm.
They're just sitting on maybe anywhere from 2 to 6 feet of dirt. And if you get a good wind down there, they could blow over.
I noticed there's
The
a
sign's
sign
missing.
missing. And I'm trying to remember what it said. But I have a picture of it from a while ago, so we can compare it to replace it. So,
And we need to re-rock that road again. That one didn't get much.
no, up top it's looking a little.
Yeah, scarce.
That's not Astro Park. That's my backyard. What did I put that one in there for? So, just a fair warning for those who are going down to Astro Park. If you're walking around the woods,
Yep.
there are ticks. So don't do like I did and get a tick. That's all I'm going to say.
Yes.
Oops, I didn't mean to close that actually. I need to go back here. Right. So old business. Ground school's table for now. The purchase of the 6-inch Next Star was going to be overcome by events because of the donation of a Celestron SLT 130. Was there anybody wanted to have any discussion on that?
The SLT's got the same go-to setup that the Next Star does because it's a Next Star. I got one of the 130s.
Mm-hmm.
So,
well, as part of the executive meeting last night, we discussed the fact that membership took a vote on doing the purchase of the scope, but that a donation has come in that will supplant that need to purchase the scope. And we just wanted to be open and transparent that we don't necessarily need to spend that money. on it.
You can still get some goodies for the other one.
Here's the thing. I bought a battery pack for it and I'm donating it. So we don't need a battery pack.
No, just more eyepieces maybe.
True.
That's about all you need with that thing.
Stafford, what do you think on the eyepiece front?
Yeah, you could probably get a nice set of Orion Plossos for about $100. We just did a similar thing for one of the prizes at the Nebraska Star Party. So, so that would probably take care of that issue anyway.
Okay.
I have a little Celestron observer kit thing. It's got like 2 eyepieces and a Barlow I could donate.
Wow.
For any of the scopes that anybody wants to apply them to. I don't know.
Okay.
I don't, they're duplicates of stuff I already have. I don't have any use for them.
The scope actually has a 10 and a 25 that comes with it. It also has a case.
Yeah, I don't know what is even in that kit.
Yeah.
Tripod fits perfect in a big chair, bag for a folding chair.
Well, the bag is big enough to fit pretty much everything in it. It fits the tripod, the tube, the eyepieces, and if I think John said, is that a Talent battery pack?
Yep.
Then it'll fit that too. It's a big Celestron bag that you can carry. I mean, I wouldn't carry it myself. It's a little too heavy for me, but anybody else could.
This is the tripod for it. Other than mine, I guarantee is a lot dustier than yours is.
Mine is pristine clean.
That's because it's in the bag. Mine's not.
That kit I have is a 17 and a 6 and a Barlow, and then a red and blue filter and a moon filter.
Oh, well, there you go. Still fits.
So for whatever scope they want to apply that to for the library.
All right. I would coordinate with Stafford.
That would, if you use a 10 and a 25 already, that would very nicely round out the eyepiece collection for that SLT 130.
Yeah, whenever I give that 10-inch Dobsonian back, I can bring that with it.
All right.
Just saying, Steve Skinner, did you have any input on this discussion?
No, I just thought it was a good idea to have it. So,
okay,
I think that's fine. What the decision is fine.
Okay, thank you. The other old business was the youth program chair, maybe this fall, and the program chairperson and forming a committee. So, is there anybody here who would like to be on a committee to find a program chairperson, or would like to be the program chairperson?
Being on the committee does not preclude you from being nominated for the program chair.
Mm-hmm.
What does the program chair do?
Well, let's find out. I have the description here. You're essentially going to be, it's like finding the person who speaks at the meeting for the program, right? And the person speaks roughly 35 to 45 minutes. And it goes between the beginning of the meeting and the business meeting. There's also a component, which we did not do last year because we were doing pandemic, but for the holiday gala gathering that happens in December, the program chair helps to coordinate some of the door prizes.
So you pester people.
Yeah.
Yeah. You could put it that way.
That is the funnest part of the position.
True. Let's see. I had a
Should
officers.
we be nominating you, Mike, for the program chair? Are you interested?
I don't know if that's for me. I don't know enough yet to be
Oh, you're
useful.
not presenting.
Unless you want to.
You're finding other people to present. Unless you want to, don't let us stop you.
Louis a good teacher to go pester people.
No, you gently coax them. You don't pester them. You just gently.
Not Louis.
That's semantics.
Got something to say tonight? Come on. How about tomorrow night?
It varies from person to person what level of pester you might provide.
Might be required.
Oh, that you might enjoy.
Pointed stick.
Yeah, we got a whole bunch down there at the Star Park right now.
So the official description is this program chair solicits members to provide programs during meetings and lets the Stella editor know what the program information is coming up and buys door prizes for the holiday gala. The time requirements are roughly a half an hour per month. So that is those numbers for that.
I think it does not have to be a member. It could be a guest speaker.
That's true. We have had situations where we've had speakers from the outside come in and do talks. Even big talks.
Some of our best talks, in fact.
Mm-hmm.
Yep.
Even before we did we have remote speakers before?
Long time ago.
Okay.
Man, probably easier now with Zoom.
Yes. I know that at Nebraska Star Party a number of years ago, they had Doug Ellis remote in from JPL, and he gave a talk.
Yep.
And that was up in Valentine, so I think there's more bandwidth.
Anything's possible.
Yeah. Let me see. I don't see. There's no new business. Oh, Mike.
Which Mike?
I'm sorry. Motorson.
Yes, sir.
Did you use a lot of gas in the chainsaw?
It was my boss's, so it's fine.
So your boss is donating the gas.
As far as he knows, sure.
Okay.
Tax write-off. Give him a piece of paper.
So that leads into my next question. How was the bar on the chainsaw?
A little wobbly now, but I'm not worried about that. I'll take care of that.
Okay, because all right. I just want to be sure because I don't want people to be out of something if there was an issue in regards to the org.
Bars are cheap either way.
Okay.
How long was it? 16
inch.
18?
Can you put a longer bar on a chainsaw that you
Depends
have?
Depends on the CC of the engine.
Okay.
Yeah, it depends on the motor size.
So that's the limiting
size.
I'm not really. I mean, I have a small chainsaw, but that's it. So, New World.
It's a nice saw. Steel.
Yeah, it is.
Mm.
Does anybody have any new business? Any concerns or questions? Very well. The next meeting is May 7th, 2021. That's a Friday. Haha. See, it's a joke.
Mm-hmm.
2021 here on Zoom. Is there a motion to adjourn the business meeting?
Mike motions to adjourn.
Tom will second it.
RCIN.
Yeah.
Second has been made by
Croatian.
Tom Wilson. A motion has been made and seconded to adjourn the business meeting. All those in favor say aye.
Aye.
Who's opposed? Say nay. Okay. Thank you. Now